hopefully you worked through that last section 3.3 and got some of those perfect cubes and perfect squares memorized, because this is where it's going to become really helpful. So in this section 3.4, it's going to take us 2 days to cover this. We're going to cover two different topics. So the I can statement is I can find roots of perfect squares, and perfect cubes. Perfect squares and perfect cubes. We're going to find roots of those. Now, if you haven't heard of roots before, we're going to talk about those. So the warm-up is making sure that you understand these right here. Now, these are all perfect squares. They are on the list that you should have memorized. You should memorize up to at least 12 squared. So 1 squared is 1, 5 squared is 25, 7 squared is 49, 11 squared, 11 times 11 is 121, and 8 squared is 64. Okay, again, you should be able to recall those very quickly. Now, a lot of what we do in math, it comes down to this. We learn how to do something, and then we learn how to undo it. We do it forwards, and then we undo it. We go backwards. So like we learn how to add, and then we learn how to subtract. We learn how to multiply, then we learn how to divide. Now, when two operations undo each other, then they have a special name. We call those inverse operations. So when we're talking about inverse operations, those are operations that undo each other. And a radical sign is one of the tools that we use to undo an exponent. So a radical is one of the tools that we use to undo an exponent. So we're going to talk about radicals and roots right now. So there are three parts to a radical expression. There's the radical sign, the radicand, and the index. Now, this kind of thing that looks kind of like a division box or something like that with a little hook on the end there, a little check mark right there, that is called a radical sign. So this right here is the radical sign. So I'm going to write radical sign. Radical sign. Now, this number underneath here, notice that it's a B. That is called, it's kind of like the base, but we call that a radicand. So that's called the radicand. So the radical sign is the little check mark box right there. The radicand is the number underneath. And then the index, the index is the number that goes in the little crook there. Now, if there isn't an index, so if it looks like this right here, then we assume the index is a 2. So what that means is it's what we call a square root. So if there's nothing there, we assume it's a 2, and we'd call that a square root. So if it was there, it would look like this. It would have a 2 right there. But if there's nothing there, then we get to assume that it's a 2, so it would be a square root. We're going to talk about square roots, and we're going to talk about cube roots. So this is what square roots are going to look like most of the time. So just like absolute value bars are asking a question about the number inside. So remember, absolute value is asking this. What is the number's distance from 0? Okay, a square root symbol is asking a similar type of question, but this is the question that it's asking about that number underneath, about the radicand. So the question that it's asking is, what number squared gives us this number? That's why we call it a square root. So when we see something like this, when we see, we could say radical 9, or we could say the square root of 9, it's asking what number do we square to get 9? So let's think about this. What number do we square? We've got that list of numbers that we were talking about getting memorized. Well, the number that we would square to get 9 would be 3. So the answer on this one is 3. And here's why. Because if we write that as 3 times 3, what the square root does is it changes a group of 2 factors on the inside of the radical into 1 factor on the outside of the radical. Okay, so we've got these 2 3's. This would be 3 squared. We could kind of write it like this, 3 squared, and these kind of undo each other, so we get right back to the 3. If you take 3 and square it and then take the square root, you're right back to 3. So again, the question here is, what number do we square to get that number that's underneath, that radicand as we call it? Again, notice that all of these are square roots. They don't have an index, so they're all square roots. So the question here is, what number do we square to get 25? What number do we square to get that number underneath? Well, we square 5, so there's the answer on this one. What number do we square to get 81? Well, the number we square to get 81 is 9. What number do we square to get 1? Well, we square 1 to get 1. These are a little bit more difficult. 256, do you remember what that is on your list? 256. That is a perfect square of 16. So if I take 16 and I square it, I get 256. So the answer on this one is 16. And notice this kind of backwards relationship. If I take 16 and I square it, I get 256. If I take the square root of 256, I get right back to 16, and that's why we call these inverse operations of each other. And then we've got one that you should recognize, the square root of 144, or radical 144, we'll say sometimes. So that's going to be, what number do we square to get 144? That's going to be 12, okay? So there are some basic square root problems, and there are a couple things that you want to keep in mind when you're doing square roots. First of all, you cannot take the square root of a negative number. So for example, you can't take the square root of -4, because if you stop and think about it this way, what we're asking is this: what number do you square to get -4? Well, if you take a number, let's say it's positive, and you square it, it would be a positive times a positive, and you'd end up with a positive instead of a negative. So you say, well, of course it would be. They're all positive. What if we took a negative and we did the same thing? What if we took a negative and we squared it? So we'd have a negative times a negative, and what's a negative times a negative? It's a positive, okay? So there's no way that we can take a number and square it and get a negative, okay? So that's why we can't square something and get a negative. And then the next thing is, fractions may not be your favorite type of number. Fractions can be a pain sometimes, but it turns out that radicals, and I'm going to write it this way, radicals play well with fractions. That means there are a lot of really nice properties of radicals that work really well with fractions. So that's one of the reasons why we stress learning how to use fractions really well and getting used to seeing those in problems. So let me show you why. If we're taking the square root of a fraction, what we can do is we can do this. We can do the square root of the top and put it over the square root of the bottom, and then figure them out separately. So we take something that has a fraction in it, and then we figure out the square root of the top and the square root of the bottom, and then that would be the answer. So let me show you an example of what we're looking at right here. So on this one, we do the square root of 25 on the top, the square root of 49 on the bottom. Square root of 25 is 5, square root of 49 is 7, and that's the answer right there. Now, if you want to break these apart every single time and write it like this, that's totally okay. If you want to just stop and think, oh, I know this property, it's the square root of the top over the square root of the bottom, and then skip this step in between, I'm totally okay with that. Just make sure you're using the property correctly every single time. So the square root of 81 is 9, and the square root of 169, stop and think about that again, that was 13. If you have to refer to your list occasionally, that's not bad, but you do need to memorize those well enough that you can recognize them. If nothing else, you look at the next one, you go, oh, wait a minute, 225. Yeah, that was on my list. That was the square. That was the perfect square of 15. So this is going to be 15 on the top. Square root of 16 is 4. The number we square to get 16 is 4. So there's our answer right there. And again, notice this relationship right here. Notice that if we square 5, we get 25. If we square 7, we get 49. If we square 9, we get 81. If we square 13, we get 169. If you square 15, you get 225. If you square 4, you get 16. So there's really this inverse relationship going on. And then take a look at this one right here. We'd have the square root of 1 on the top and the square root of 100 on the bottom. Square root of 1. What number do we square to get 1? That would be 1. And what number do we square to get 100? That would be 10, so our answer on that one is 1/10. So again, fractions work really well with radicals. They're really easy to use. There are a lot of nice properties. So let's take a look at this one right here. These come up all the time. I do have these in order, so let's take a look here. The square root of 1 is 1. The square root of 4 is 2. Okay, square root of 9, what do you square to get 9? It's 3. Square root of 16, so you can see the pattern here. This would be 4, this would be 5, this would be 6. Square root of 49 is 7. And if you say these out loud, if you're saying like the square root of 64 is 8, and the square root of 81 is 9, and the square root of 100 is 10, just saying those in your mind, that's going to make things much better in the long run. It's going to kind of get your memory and just kind of work that in there so that you can rattle those off really quickly, because these will come up all the time. Okay, let's take a quick look at the brain challenge right here. This is a -2 and then a radical 49, or the square root of 49. And remember, we know what this means if there's nothing in between two numbers. This means multiplication. This is implied multiplication. So this is -2 times whatever the square root of 49 is. Square root of 49 up here is 7. So the answer on this one is -14. We're going to be seeing more problems like that. All right, good luck on the assignment.